In this video, we're going to learn how to sketch graphs, particularly when the quadratic is in general form. So if an equation is in general form, it's in the form y equals ax squared plus bx plus c. Now, up to now, the only way that you might know how to sketch a graph is by drawing out a table. So for example, if I've got a quadratic like this, say y equals x squared plus 2x plus 1, and we needed to sketch that, up to now you might have had to have gone, right, okay, well, a is, in this case, if I'm relating this to the equation, a is 1, b is 2, and c is 1. If I was going to sketch that, I might draw out a table, and that would be obviously be quite long-winded. So for example, I might select values for x between a -3 and 3. And then obviously by substituting in these x values into this equation, I would then be able to find the y values. So we'd start at -3, -3 squared is 9, plus -6 plus the 1, that gives me 4. And obviously if I did that for every single value, this would take some time. I'm obviously speeding this up a bit. I've got a set of coordinates which I would plot, and that would take me a bit of time as well. So we need a better way, a more efficient way. So I've cheated a little bit and I've used the class pad or the graphics calculator to plot this. But what we can do is we can use our knowledge of general form and we can find the Y-intercept, and we do that by, of course, substituting in x equals 0. We can find any X-intercepts if they're relevant, and obviously in this case there are no X-intercepts, and that's found when y is equal to 0. And the other thing is the turning point, and I'm going to talk you through how we find the turning point when we're in general form. Okay, so I've written those things down. Now let's just talk a little bit more about this turning point. Up to now, you should know that the turning point, the x-coordinate of this turning point gives the axes of symmetry. So here we can see the turning point, x value is -1. So x equals -1 is the axis of symmetry within this graph. Now, what I've written here is the x-coordinate of the turning point gives the axis of symmetry. So to find the x-coordinate of the turning point when you have a quadratic in general form, you can use this equation, -b divided by 2a. And I'll put the purple box around this. Now, obviously b is associated with when you've written the equation in general form. Let me just write it, ax squared plus bx plus c. So obviously there's the value of b, and you want -b, and there's the value of a, and you want twice a. So it's -b divided by 2a. I'm going to give you some tips when you're sketching this kind of graph. First of all, if you've got some axes, you mark in your turning point, your y-intercept and your x-intercepts, and then you just connect all the points together to make the shape of a parabola. It should have it's symmetrical, so it should have a mirror line, which is obviously here. Let's go into an example where I show you how to sketch a graph. So we're going to sketch the following. I'm going to do the equation y equals x squared minus 4x plus 4. So what I'm going to do is, first of all, write down the values of what a is, what b is, and what c is. And I always write this sort of just over here on the left, just for my purpose. So a equals 1, b equals -4, and c equals +4. Okay, now what I'm then going to do is, as I have in all my other videos, if you've watched them, I like to set my working out in headings. So I like to have the turning point at the beginning. Then I start looking at what the y-intercept is, and I always write how to do that. So that's when x equals 0. And then the next final column is the x-intercept, and that's when y equals 0. Okay, so for each one, let's look at this turning point first of all. I'm going to use the new equation that we've just learnt. So x equals -b over 2a. So let's have a look at this. Okay, so b, as we said, is -4. So I'm going to write that as 4 over. And then a is 1, so over 2 times 1, which is 2. And then x equals 2. Now don't forget, this just gives you the x-coordinate of the turning point, and to find the y-coordinate of the turning point, I'll need to substitute the value x equals 2 into the original equation. So it was y equals x squared, so I'm going to do 2 squared, minus 4x, so minus 4 times 2, plus the 4. And if I work all that out, I get 4 minus 8 plus the 4, y equals 0. So we can now say that the turning point is at the coordinate 2, 0. Okay, let's go down to the next column, which is the y-intercept. So for the y-intercept, I'm going to substitute x equals 0 into the formula. So again, write the formula at the top. It's y equals x squared. So I'm going to do 0 squared minus 4 times 0 plus the 4 and work each one of those out. So I've got 0 minus 0 plus the 4. Y-intercept is 4. So obviously the y-intercept sits at the coordinate 0, 4. Now the x-intercepts are a little bit trickier. Remember, there's always two of them. Because it's in general point form, the first thing we need to do is go, well, does it factorise? And I'm going to look at factorising where two numbers here multiply together to make 4 that also add together to make negative 4, and of course the two numbers I'm looking for are minus 2 and minus 2, so that's easy to factorise. I didn't need to think too hard about it, so I can now put it equal to 0 and in factorised form. So write x minus 2 multiplied by x minus 2 and solve using the null factor law. So I always write my working, so I'm using NFL to solve. So by doing that, either x minus 2 equals 0, or, obviously, x minus 2 equals 0, so we've got 2, which solves to make x equals 2. Now, interestingly, we've only got one solution. That usually means when you've only got one that it does not intercept the x-axis, but it sits right on that point. So it's where the most minimum point is. And if we actually go over and look at what the turning point is, the turning point is exactly the same. All right, so that's what we expect. It's a sensible, reasonable answer. And now, of course, I'm going to sketch it. So I'll just draw up a set of axes. So the first thing I'm going to do is draw a nice smooth parabola, just touching that x-axis because we know it doesn't cut. And obviously put some arrows on there and then just label. We've got the y-intercept here is at 4 and the x-intercept there is at 2. Okay, and obviously put the title y equals x squared minus 4x plus 4. Okay, I'll just do a second example and just show you how it's done exactly the same way. So I like to set out the working. We're going to sketch this graph. We're going to do x squared minus 2x minus 3. And again, we look at, well, what's A, what's B, and what's C? Well, A is 1 here. B is minus 2 and C is minus 3. Okay, so for the turning point, I'm going to be using minus B over 2A for the x coordinate of the turning point. So that then gives me 2 over 2, which is 1. So the turning point, the x coordinate of the turning point is at 1. To find the y value, I'm going to substitute 1 into here. So 1 squared, obviously you'd have to show you working. I'm just showing you a second example, so I'm speeding this up a bit. 1 squared is 1, minus 2 minus the 3, y is minus 4. So the y value is minus 4. So the turning point is at 1, minus 4. Okay, so now I'm going to go on to find the y-intercept. So again, substitute x equals 0. So I'll just go back to the equation. It's y equals 0 squared minus 2 times 0 minus the 3. The y-intercept is at negative 3. So that's 0, negative 3. And the x-intercepts is when y equals 0. So I obviously need to factorise that. Now let's just write that equation at the top there. Obviously we're going to solve for the equation equal to 0. So x squared minus 2x minus 3. So I want two numbers that multiply together to make negative 3, that when added together make negative 2. So of course the two numbers that I need are x minus 3 and plus 1. So using null factor law to solve this, either x minus 3 equals 0 or x plus 1 equals 0, which means my solution is x equals 3 or x equals minus 1. They're my two x-intercepts, so I've got 3, 0 and minus 1, 0. Alright, so sketching, I'll just do a quick sketch and show you what that looks like. And there you go. Then that concludes